In this section, I'd like to express the Gauss Law. This is a fundamental statement about the relationship between the electric charges and the electric field. I explained how to calculate the electric field from the charge distributions. Gauss' law said if we know the electric field, we could find out the charge distributions. This is the statement of the Gauss' law. So if we consider the imaginary closed surface, by observing the electric field on the imaginary closed surface, we could find the charge inside of this region. This is a Gauss' law. Gauss' law consists of these three sentences. First one is whether there is a net outward or inward electric flux through a closed surface depends on the sign of the enclosed charge. If we have an outward electric flux, positive charge exists inside of the closed surface. If we find the inward electric flux, we have a negative charge inside of closed surface. And the second one, the charges outside the surface do not give a net electric flux through the surface. So we don't have to take into account the charge outside of the surface. This is the second statement. And the third statement is a net electric flux is directly proportional to the net amount of charge enclosed within the surface, but is otherwise independent of the size of the closed surface. Okay, so I'd like to explain each sentence step by step. So electric flux through a spherical surface. So maybe we should consider a simple case of the spherical surface. We consider charge exists located at the center. Area vector of the spherical surface is always parallel. E and ds is parallel. Then we can easily calculate the electric flux through the spherical surface, because the magnitude of the electric field is always constant on the spherical surface. Then you can multiply the area of the spheres, 4 pi r squares, and the electric flux can be calculated, Q over epsilon naught. Electric flux is independent of the radius of the spheres, so you could consider small areas or larger areas. It doesn't matter. Always electric flux is a Q over epsilon naught. Then we'd like to consider the electric flux through the non-spherical surface. Then on the surface, area vector of A, this is dA vectors, is not parallel to the E, and the angle formed by these two vectors is theta. Then if you consider the scalar product, E dot dA, this becomes magnitude of E, magnitude of A, and you have to multiply the cosine theta because of scalar product. This is going to be the theta. A cosine theta, this A cosine theta is a projections. So this is going to be the, if you consider this triangle, dA cosine theta becomes, this is ds. So E times ds. And ds is a small section of a spherical surface. ds vector is directed this direction, so parallel to the E vectors. Also, you could write the E dot ds vectors. Always, we could consider some small section of a spherical surface, even if we consider the non-spherical surface. We could consider the cone. The charge is located here, shape of the cone. So we consider two areas, these two areas. So this point is r. This distance is going to be expressed as beta r. Area of this area is expressed as ds. Then this area, because the distance becomes a beta times larger, area becomes a beta square ds. Then you could calculate flux at r is gonna be E R ds. So you could calculate. It becomes 1 over 4 pi epsilon naught Q over R square ds. This is the flux through the disk cross sections of the ds. For the blue ones, flux at beta r, the E beta r. The area becomes a beta square ds. So it becomes 1 over 4 pi epsilon naught. Q doesn't change. So r is a beta r squares, beta square ds. So it becomes 1 over 4 pi epsilon naught Q over r square ds. So this is a flux through these areas. So blue ones. And then you could compare these two forms. Actually, it becomes exactly same. We discovered flux is independent of radius of a closed spheres. Okay, so we could consider this ds, but you can choose a ds or this ds. This ds doesn't matter. It's always the same. Every part of the small section of the non-spherical surface, you can always, this area can be moved to this small section of the spherical surface to calculate the total electric flux through the non-spherical surface exactly equal to the electric flux through the spherical surface with the radius of the r. Electric flux through a non-spherical surface is the same as that through the spherical surface and becomes Q over epsilon naught. And the charge outside of the surface. Charge is located outside imaginary surface. These two should be cancelled out. So I'd like to explain. So we consider some kind of the imaginary closed surface. And the charge is located here. Then we could consider the cone. So this is, you could consider this is dA. So E vector is here. Also this point is E vector. So this point is close to the charge. So magnitude of the is larger. dA vector is here, is R. So this length becomes beta R. Then as I explained, we always considered ds primes, and also this part, ds vectors, is parallel to the electric field. Again, ds prime becomes a beta square ds. Then we could consider flux at r, E r scalar product dA. It becomes minus E r ds, because actually the direction of the E and A is the opposite direction. Angle becomes a parallelians. So it becomes a negative E ds. Flux at a beta r, E beta r dot dA prime becomes E beta r ds prime. It becomes E r ds. So if you sum up these two contributions, it becomes 0. If you consider some charge outside of the boundary, this charge outside of the boundary does not contribute to the electric flux through the closed surface. By considering this fact, if you consider this type of the closed surface, then charge is located here. Then again, you could consider cones. In this case, the closed surface got the even numbers. So negative, positive, negative, positive. So in the case of the even number, actually the flux becomes 0. If we consider the charge is located inside or inside, then actually we have a 1, 2, 3. So in this case, the odd numbers, then flux cannot become 0. It becomes Q over epsilon naught. If this charge is a Q. Charge outside of the surface does not give a net electric flux. Then we could combine all the information. Becomes Gauss Law. This is a relationship between the electric charge and the electric field. If you integrate E.ds, this is scalar product, flux over the cross surface, it becomes a Q over epsilon naught. The Q is a total amount of the charge inside of the cross surface. So Q is given by these equations. So this is one of the fundamental equations in electromagnetism.